Hey guys, today we're going to be talking about volume of a rectangular prism with fractional edges. I think last year you guys were working with volume with whole numbers, but this year we have to push you a little bit further and start doing fractions. I want to make sure that you have pencil and paper because you want to work out the problems, because I will be asking questions through the video and you will have to answer the question to be able to proceed with the video to get full credit for the video quiz. Now get your pencil and paper ready and let's get started.
Hey everyone, welcome back to Mashup Math. Anthony here. Thank you for joining me on this lesson. We are going to explore right rectangular prisms, how to find their volume, and what to do when fractions are involved. You ready? Hey guys, welcome back. We're going to start off this lesson on finding the volume of right rectangular prisms, which is a shape that we're all familiar with when we get those Amazon packages in the mail. That box is a right rectangular prism. And we are going to think about these kind of figures in terms of their volume. Now, the volume of a rectangular prism is going to be dependent on its dimensions, in other words, its length, its width, and its height. So, for example, let's consider a rectangular prism with a length of 10 inches, a width of 4 inches, and a height of 7 inches. Now, we should have a basic understanding that the volume of a figure is a measure of the amount of space inside of that figure, or how much it can hold inside. Now, you may also know that in geometry, we express volume in cubic units. So, in other words, the volume represents the number of unit cubes it would take to fill the entire prism. And since the length, width, and height of the prism shown is measured in inches, our unit cube will have a length of 1 inch, a width of 1 inch, and a height of 1 inch. So if we were to take our rectangular prism and completely fill it from bottom to top with these 1 inch unit cubes, and then counted the total number of cubes, that final total would represent the volume of the figure. Now, counting every single one of these cubes would take a very long time and is not the most efficient way to find volume. Luckily, rectangular prisms have certain properties that allow us to apply general rules for finding volume, and we are going to explore those rules now. So let's imagine that we only use those 1 inch unit cubes to fill the bottom layer of this rectangular prism. To fill this bottom layer, we would need 10 cubes along the length and 4 cubes along the width. So basically, we would have 4 rows of 10 1 inch unit cubes. So to figure out the total number of 1 inch unit cubes to cover this bottom layer, we can just multiply 10 times 4, and our product is 40. So we have 40 cubes comprising this.
Okay, before we went on spring break, we were talking about area. Now, if you can see, the shape on the bottom of this rectangular prism is a rectangle. If we multiply the length and the width, we get the area, which is 40. Now, after we get 40, what are we going to do with the 7? Answer below.
This bottom layer of the rectangular prism. Now, to determine how many of these 40 cube layers it would take to fill the entire prism, we have to look at the height, which is 7 inches. Which means that we would need 7 layers of 40 cubes. So by multiplying 40 times 7, our product of 280 represents the total number of unit cubes it would take to fill this entire prism. So now we can conclude that the prism has a volume of 280 1 inch cubes, or 280 cubic inches. So now let's go back to thinking about some of those general rules that apply to finding the volume of a rectangular prism. So in that last example, we found volume by first figuring out the number of cubes in the base layer and then multiplying that value by 7, which represented the height of the figure. Now to find that number of cubes in the base layer, we found the area of the base, in this case the length times the width, or 4 times 10, and multiply that by 7. Now 7 again represented the height. So we can conclude that we can define the volume of a rectangular prism by multiplying the area of the base by the height.
Cool.
And thinking about volume in this way should help us to better understand the more familiar formula defining the volume of a rectangular prism, which is length times width times height. So in this case, that letter B, that base, represents the length times the width. So now moving forward, understand that you can use either formula for determining the volume of a rectangular prism. So now let's go ahead and try another example of finding the volume of a rectangular prism. Now in this case, our units are centimeters, so we want to figure out how many 1 centimeter unit cubes it would take to fill this figure from bottom to top. So let's go ahead and use the volume equals length times width times height approach. So in this example, the length and width are represented by 7 centimeters and 2 centimeters, and the height is represented by 5 centimeters.
Okay guys, now is paper and pencil time. I want you to take your paper and pencil. For L, I want you to use 7. For W, use 2. And for height, use 5. Multiply the first two numbers together, take the answer, and then multiply it to the last number. Answer below, and then proceed with the video.
So our next step is to substitute these values into the equation and then multiply. Now the product of the length and the width, 7 and 2, is just 14, which represents the area of the base, multiplied by the height of 5. And our product represents our volume, which is 71 centimeter cubes. And again, we can visualize this as 5 of those 7 by 2 base layers stacked up from bottom to top. So now let's take our understanding of volume to the next level. For example, what if instead of expressing volume in 1 centimeter unit cubes, we wanted to express it in half centimeter unit cubes? Now, since this is a smaller unit, we should see that it's going to take several more of these smaller 1/2 centimeter unit cubes to fill the entire rectangular prism. Now, since the dimensions are half the size, we have to divide the length, the width, and the height by 2. Now, what this does is it doubles the amount of cubes on the length from 7 to 14. It doubles the amount of cubes in the width from 2 to 4. And it doubles the amount of cubes in the height from 5 to 10. Now, be sure to understand that the volume of the figure has not changed. That is, the amount of space inside of this rectangular figure is still the same. However, since we are now using smaller unit cubes to fill the inside of the space, our volume will be represented by a larger number. However, the unit will be smaller.
Okay, now is the time for a timeout. Look at the question. Describe how using different size unit cubes can affect the way we express the volume of a rectangular prism. This is something I want you to listen for, and I want you to write down a response, because after the video, you're going to log into the discussion post and you are going to write your response.
So to find the volume of the figure now in terms of 1/2 inch unit cubes, we use the same approach, and that is using the formula volume equals length times width times height.
Okay, now I want you to take the new numbers, the 14, the 4, and the 10. I want you to multiply those all together, and I want you to answer the question below on what your answer is for the volume to find it with the new unit cubes.
So by substituting 14 and 4 in for the length and the width, and substituting 10 in for the height, all we have to do is multiply. In this case, 14 times 4, the area of the base is 56. Multiplied by 10 is 560. So the volume of the figure expressed in half centimeter cubes is 560. So now let's go ahead and take one last look at the difference between the two different units of measurement that we use to express the volume of that rectangular prism. So again, we use 1 centimeter cubes and 1/2 centimeter cubes. So in terms of 1 centimeter cubes, the figure's volume was 70, and in terms of 1/2 centimeter cubes, the figure's volume was 560. So by comparison, we should see that a 1 centimeter cube is the equivalent of 8 1/2 centimeter cubes. So when we compare our volumes, our 1 centimeter volume was 70, and if we multiply 70 by 8, our result is 560.
Cool.
So by visualizing this relationship, we should be able to better understand how we express the volume of a figure and how that volume is dependent on the unit that we choose to use. So now let's go ahead and take on one final example where we want to find how many 1/4 inch cubes will fit inside of the prism shown. Now notice that this prism has what's called fractional edges. That means that the dimensions of the length, the width, and the height are mixed numbers and include fractions. So in this case, our unit cubes are 1/4 or 1/4 inch in size. So we can imagine a 1 inch cube, a 1/2 inch cube, and of course a 1/4 inch cube, which will be very small, so our volume will be represented by a much larger number than if we had used a 1 inch cube. Okay, so even though two of our dimensions include fractions, we still use the same approach to finding volume, and that is the length times width times height formula. So first, let's look at the length of the figure, which is 1.5 inches. We can think of this as a 1 inch unit cube alongside half of a 1 inch unit cube. And our next question should be, what would be the equivalent in 1/4 inch unit cubes? Now we can think...
Okay, I just wanted to stop right here because I wanted to talk about the 1/4 unit cube and how many is going to fit into the 1 1/2 inch of space. We're going to look at the denominator. The denominator tells you how many of those cubes is going to fit in 1, but our number that we're working with is 1 1/2. So how many of those 1/4 cubes is going to fit in the space of 1 1/2?
Think about this in terms of money. A 1/4 inch unit cube would be like a quarter, and that 1.5 inch measurement would be like $1.50, 1.5 or 6 quarters. So now we can replace that measurement of 1 1/2 inches with 6 1/4 inch cubes. So
did he replace the 1/2 or the 3 3/4 with 6? When we put 6 in there, which number are we taking out?
In the case of 1/4 inch cubes, our length is 6. Now, since our width is 1 inch, we know that it would take 4 1/4 inch cubes to cover that width. So we can say that our width in terms of 1/4 inch cubes is 4. And we can apply the same thought process to the height, which is 3 3/4 inch, which would be equivalent to 15 1/4 inch cubes. So we can replace our height with 15. And now to find the volume.
Now to find the volume, you have to multiply 6 times 4, take the answer and multiply to 15. Go ahead and write it on your paper and let's see if you get it correct.
All we have to do is multiply 6 times 4, which is 24, multiplied by 15, results in our volume. So we can conclude that it would take 360 1/4 inch cubes to fill the entire prism. So just keep these strategies and concepts in mind as you continue to explore the properties of right rectangular prisms, especially in terms of their volume. And that is all for this lesson. Thank you again so much, everyone, and we'll catch you all next time.
Okay, that concludes the first lesson on finding volume with a rectangular prism that has a fractional edge. Now, once the video stops, you are then going to log into the discussion post and then type in your response and hit reply. I'll see you soon.